Okay, so this is the first problem of Atcoder Beginner Contest 323. And this problem we're given that we have a string S of length 16 that consists of zeros and ones. So if the ith character of S is 0, for every number between I, for every even number I from 2 to 16, then we have to print yes, otherwise we have to print no. So this is a straightforward implementation problem. And like this is my implementation in this. I've just taken a flag which is initially set to 1, and for each of the index I'm starting from 1 because like my string S is 0 indexed. So this is second position. I'm starting from second position. I'm starting and I like incrementing each time with 2. So I'll be going over all the even positions and I'm checking that if they are all zeros, then my F will remain, flag will remain 1. And if it is 1, I can finally print yes, otherwise I'll print no. So I hope this is clear. So let's go to the next problem. So this is the next problem. In this problem, we are given that there are n players numbered 1 to n, and for now they are going to, like, these players have played a robin round tournament, and for each match in this tournament, one player won and one player lost. So the result of the matches are given as n strings s1 to sn. And if I is not equals to j, the jth character of si is either a 0 or an x. This 0 or o, it's not a 0, it's a o. So this o means that player I won against player j, and x means that player I lost against player j. If I is equals to j, then this is just a minus symbol. So the player with more wins ranks higher. If two players have the same number of wins, the player with the smaller number gets higher rank. So we need to report the players' numbers of the n players in descending order of the rank. So this is just a like sorting problem, and we can just first count how many, like what are the number of wins for each player. First, we can just count what are the number of wins. So wins for each player, and since we need to sort it accordingly, we need to have the like the numbers of players arranged. We can make a pair of wins, comma, player number. And like let's make a vector of these values, and once we sort it, we'll get like according to this win. So instead of having these wins, like the player who have went the most number of times will be at the bottom of this sorted array, right? Or at the bottom of the list. So instead of doing this, let's make a pair of kind like number of loses from a player wins. Now if I sort this player number, so now if I sort this, the player which lost the least number of times will be at the top. And if two players are having the same number of loses, then they'll be sorted according to their player number. So finally, if I sort my pairs according, like my pairs are this and I sort my vector, I can finally print all of these values, that is player number in this order. So let me show the, so this is the implementation. First I'm taking n as input, then I'm taking string s as input, like all the n strings as input. This is my pair vector. Now I'm counting how many times each player is losing, because see, if there are n-1 matches that a player is going to play against all the n-1 opponents, right? So if a player is losing like 2 times, then by default, like let's say n was 10, so he's going to play 9 times. Each player is going to play 9 times. So if a player is losing 2 times, then he'll or she will be winning 7 times. So that's why you can either do this using the number of times a player loses or the number of times a player wins. So I have taken the number of times each player is losing. I'm inserting that thing. This thing is the number of losses, and this thing is the index of the player, like the player number. After I sort this, I'll get this B. as the order that I want for my players. Like they are arranged in from highest rank to lowest rank. So is it clear? Yes, no? Let's go to the next problem. So in this problem, the programming contest World Tour Finals is underway, and there are n participants, and half of the competition time has passed. Now there are m problems in this contest, and the score AI for the problem I is a multiple of 100 between 500 and 2500 inclusive. For each I 1 to n, we are given a string s that indicates which problem player I has already solved. So this is of length m, and if it is 0, then it means that the player I has already, like if it is an O, then it means that a player has already solved that problem. Otherwise, if it's an H, then the ith player hasn't solved that problem. So now for each, like the total score of the player I is calculated as the sum of the scores of the problems that they have solved plus I. So for the third player, it will be number of problems that that player have solved, like the scores for those problems plus 3. And now for each of the players, we have to find at least how many problems that player has to must solve that the score of that player is more than all the players' current score, and all the like none of the players is have solved all the problems till now. So it's always like the answer is always defined, right? So how to solve this problem? See, first of all, we can find the current score of each player. Current score of each player. And let's like you can do this anyway, but like we just like one of the ways to do this is insert all of these in your multiset. Why? Because see, then when we are finding for each player how many problems do they need to solve more, first of all we can remove their score, remove player ith player score, ith player score from this multiset, and then the maximum value in this multiset, like your final score should be more than like the player ith score should be so player I score should be more than the maximum one in this multiset, right? So how to do this maximum in multiset? First of all, we need to find what are all the problems that player I can solve. So let's make another multiset for that to store multiset to store the score of problems that are not yet solved. So after that, we'll like while this condition is not true, we'll keep taking the maximum from this multiset, add it to the current I player score, and increase our answer by 1 for the ith player. So finally, once this condition becomes true, we'll print our answer for the ith player. But we like you just have to each time you have to take the maximum of this multiset and add it to your player I score. Is it clear? Yes, no? So let me show you the implementation. So here, first of all, see, I have taken n and m as input. Then I'm taking these are the problem scores, and these are the n strings that will tell me whether the ith player has solved a problem or not. Now this is the multiset for storing the current score of each player. This is just to score like again the current score for ith player. This is just for like since the score for ith player is nothing but the problems that the score corresponding to the problems that that player had solved plus I. So this is that thing. So initially score is nothing but I, and then for I'm finding what all problems the ith player have solved. If they have solved the ith problem, then I'm adding AI to C. Finally, I can insert this in my multiset and also in my vector. Just like I'm storing in vector just to know whether like what was the score of the ith player. Then in order to find the answer, I have this temporary multiset and going from 1 to n. First, I'll erase the score of ith player from multiset. That's why I needed this vector. So I'll erase the current player score from multiset. I'll clear my temp multiset. I'll calculate how many problems can ith player solve now, like that she hasn't solved till now. I'll insert their score in my multiset, this temporary multiset. So this is the current score, right? V of I. Now this is my answer. While this C is less than or equals to maximum in my multiset. Multiset is nothing but multiset is having the score of all the other players. So the maximum of that, if the C is less than maximum of all of those, I'll first increase my answer. Like ith player needs to solve one more problem. Then I'll increase my current player score with the maximum of temp. Temp was having all the problem scores that the ith player didn't solve till now. Finally, I can erase this value from my temp. Once this loop gets terminated, I'll insert vi back in my multiset and I can print the answer for the current player. Is it clear? Yes, no, anything? Okay, so let's go to the next problem. So this is the next problem. In this problem, we are given that initially there are n sizes of slimes and specifically for each I from 1 to n, there are Ci slimes of size Si. Now, Takashi can repeat slime synthesis any number of times in any order. And slime synthesis is performed as follows. Choose any two slimes of the same size. Let this be X. And a new slime of size 2X will appear. Then the original two slimes will disappear and we have to finally minimize the total number of slimes. So see, what is see we are given that initially there are n slime and we are given that this is the slime size S and the number of these slimes is C. So S1, C1, S2, C2 and all S's are unique. So how to solve this problem? See, what we can do, first of all, each time the number of slimes, see, if we have, see, let's say two length slimed, we have three. So we can choose two of these slimes and we can make them of length, like we'll get one slime of length 4 and we'll have only one slime left here. Yes, no, this is the thing that we are doing, right? In one operation. So first of all, if you look at this, see, C is at max up till 10 to the power 9 for each number, right? So we can have at max how many operations? On one length slime, we can have at max log 2 10 to the power 9 operations, not more than this, right? Because each time the number of slimes get decreased to half. Yes, no, anything? If I started from 4 slimes, I can first make them 2, like the count, and then it will become 1. I cannot go more than farther than this, right? Let's say there was 10, there were 4 slimes of length 10. Then there will be 2 slimes of length 20. Then there will be 1 slime of length 40. I cannot go further than this. Can I? Okay. So this thing is also clear. Is it clear? Yes, no. What is S into C? Okay, it's clear. Now, what will be the maximum length? Yes, the maximum length. What is the maximum length? The maximum length can be like each time S is getting multiplied by 2 and C is getting half by 2. So the maximum length can be something like s into c, not more than this, and this is itself 10 to the power 18. Like it is not more than that. So what we can do, we can have, like we can insert all slime lengths, let's say in a set, and for each like value we can have an ordered map, an ordered or an ordered map. You can have anything. So let's say you're having a map like this, will give you, the purpose of this map is a map to give you, that gives like a number of slimes of length, let's say s. So if I do mp of s, this will give me number of slimes of length s. Now we can iterate over this set. Like while this set is having size, I'll pick the slimes of smallest length. Like this is having length of slimes only, right? So I'll pick this smallest length slime, smallest length slime. I'll find the how many times they appear. Then I'll take x by 2 into 2, like the maximum number of slimes that I can take. I'll take all of those slimes, decrease from this number. After this, either this will be 0 or it will be 1, because I'm taking this thing, x by 2. If x is the number of slimes that are, x is the number of slimes that have the smallest length, I'll take x by 2 into 2, just because I can take only 2 slimes in one operation, right? I cannot take one slime. So I'll take these slimes. I'll make their length as 2s. So my MP of 2s will get increased by how many times? It will get increased by x by 2, because x by 2 more slimes are here now, if x was the number. And my MP of s will get decreased by this. Is it clear? If x is the number of slimes of length s. And I'll keep iterating over my set while my set has size. Is it making sense? Yes, no? Is there a doubt or is it clear? Answer is now, finally the answer will be nothing but I iterate over my map, and for each length find how many times do I have a slime. Like this is nothing but MP of 2s is giving me how many times I have, like how many slimes do I have of this length. So finally, for each iterate over your map, and answer is nothing but the count of all the slime lengths. So MP of, let's say, I. So how many times I is appearing? Is it clear? So there is no doubt, right? I'll move to the solution, like implementation. Yes, no, anything. Okay, implementation. So this is the implementation. In this, I have first taken n as input. Then I'm taking all those pair of SCs as input. The first value in this pair is the slime length S, and the second is the count C. Then I'm taking a set. So instead of SL, I should have taken it as ST. But anyway, so this is the slime length set, and this is an unordered map count, which will give me how many times length I slime is there. So for each of these slimes, I'm first inserting their lengths in SL set, and I'm also counting them. Like this slime, this length slime is appearing these many times. This SS is nothing but second. So since this is a pair dot second, this is like pair dot first, pair dot first. So this is S, this is also S, and this is C for current slime. Now while my SL is having some size, that is, there are some slimes that I have like yet to be done, like yet to be covered in the set. I'll find the smallest one. I'll find the smallest one, and I'll erase it from SL, like this length. Then this is the number of times I can take, like the number of times I can take slimes for this length. So count S divided by 2 into 2. If X is 0, I can simply continue. Otherwise, I'll first decrease my count S by X, and I'll increase my count of 2S by X by 2. finally I can insert this in my SL. If it is already inserted, no problem. If it is not inserted, it will be inserted because now I have slimes of this length also. Finally, my answer is nothing but I'll iterate through my count map and I'll increase my answer with count of each of the slimes. Finally, I can print my answer. Is it clear? Okay. So let's go to the next problem. So in this problem, we are given that Takashi has a playlist of n songs. Song I lasts for ti seconds, and Takashi has started random play of the playlist at time 0. Now, random play repeats the following. Choose one song from the n songs with equal probability and play that song to the end. So here songs are played continuously. Once the song ends, the next song is chosen immediately. Again, randomly it's chosen, and the same song can be chosen consecutively. Like there is no such thing like if a song was currently playing, it won't be played again. So we have to find the probability that song 1 is being played at x plus 0.5 second. This 0.5 second is just because like it is playing at that moment. So basically, since each of these times are integers, they're like each song is going to start at some integer time only, but this is just to make sure that you are between that second. So like it started before or at this exit second, and it didn't end at this exit second. So basically you have to do this thing. So we have to find the probability that the first song was getting played at time 0 modulo this number. So first of all, see, there are some songs, and let me write the constraints too. So constraint for this problem is n is so this thing n x is 0 to 10 to the power 4, and we have times as 1 to 10 to the power 4. See what we can do. First of all, at try to find what is the probability. See what is the probability of song 1. Instead of finding the probability of song getting played at some like xi second, let's try to find what is the probability that song I started getting played at ith second. So what is the probability that this probability will give me? Probability, let's say probability I comma time. This will give me ith song started playing at th second. So first of all, what is the probability of that zeroth, like the first song, not 0. Let's say like we have to answer for the first song. I'm taking my songs one index, starting from one index, right? Starting from 1. So what is the probability that the first song started at 0? What is this? Why is it 0? Like each song has equal probabilities, so it will be 1 by n. Perfect. So 1 by n percentage mod. So you can calculate this using taking inverse of n. So you take inverse of n, that is nothing but the probability of each song. So probability of 1, 2, and up till n. Probability of all of these is same, that this song is playing at 0th instance is same. Right? Yes, no? Now, tell me one thing. How to calculate further probabilities? See, we can do something like we can start from, let's say, j. Like j is the time instance. Let's say int time instance. So at time this, we'll start from 1. Why? Because we have already computed for 0. Now, time is less than or equals to x. We are only going up till x, and time plus plus. This is the time that is like currently we are trying to find what is the probability for each of these songs to get started. So this is inside a for loop. Now, what we can do, see, each of these songs, what can I do? See, first of all, I want something like what was the probability here. I need what is the probability that we will reach that like some songs have ended after some songs, some sequence of songs, ended at time at this time. This time is basically this time. So how many, like, what is the what is the total probability that I took some sequence of songs and they ended at this time? Like I took maybe one song 1, 3, and 2. They have ended like 1, 3, and 4. They have ended at 5 instance. I can take also 1 and 2. They will also end at 5 instance. So what is like the probability is nothing but probability of choosing any of these two sequences. Like there are many ways I can go, right? Yes, no. Okay. So if I get this thing, how can I calculate probability for each of these? See, if I'm able to get just this probability, I can easily calculate probability for each of these songs. I can easily calculate probability prob of I, comma, this time. How? I'll say that this is nothing but probability. Let's call this as probability 2. This thing. Let's call this as, this is probability 2. Probability 2 is nothing but what is the probability that after some, and probability 2 of this time. Like this is a vector, this is a symbol. Earlier one was a 2D vector, this is a 1D vector, and the probability 2 of time will give me what is the probability that some sequence of songs ended at time, at this time. Okay. And now I can, what can I do? I can simply write probability I of time as probability 2 at this time into 1 by n, right? Because why? See, at I can reach this time, I can end all the songs with this much probability. Like I can end some sequence of songs at this time with which is this much probability. And after that, starting this song, ith song again has a probability of 1 by n. Is it making sense? Yes, no? Simply this thing, right? Now, how to calculate this probability 2 of time? Probability 2 of time is nothing but, see, for each of these, what is happening? See, for each of these, this is ending at T1. This song, like this will not end at, but this is the duration of this song. This is the duration of this song. This is the duration of this song. So when I started all of these songs at 0, what is the probability that after some sequence of songs, I'll reach, like my songs would have ended at T1. So probability 2 of T1 is also 1 by n. Probability 2, this is 2. Probability 2. Probability T, like what is the probability that I have to choose another song at T2 instant? That is only what is prob 2, right? So this is also 1 by n. So for all of these, probability 2 of Tn is also 1 by n, right? Like I have to choose another song at this instance. That this is only this thing, right? What is the probability that I have to choose another song at this time into 1 by n? 1 by n because I have again n options and I'm choosing the ith song. So is it making sense? Like for the first time, I can do probability to calculate like this, right? Yes, no. If it is not clear, I'll explain it again. Okay, it's clear. Now, for the first time, it's okay. After this, what can we do? See, we are choosing ith song at this instant. We are choosing ith song. We are choosing ith song at this time. So what can we do? See, we know that the duration of ith song is ti, seconds or minutes, right? So what we can do is, if t of I plus time like this song started at this time and it played for ti minutes, if this is less than or equals to x. Why less than equals to x? Because I'm only considered for the first x minute. After that, if some song started playing, if after at some instant x plus 1 song started playing, it was definitely not playing at x plus 0.5 seconds, right? So I'm only worried about the songs that started playing from 0 to x. So if this is ti plus time is less than x, I calculate my probability 2 of this time. What is the time? What is the probability that I'll have to choose some song at this instant? It is nothing but, can you tell me what it will be? Probability that I had to choose song at this time into 1 by n. Yes, no. And you have to add these, not just. So the solution is clear till now, right? This is the complete solution. Like, there is only one optimization that we can do. But first of all, is this clear? Like, start with this probability and then this is how you calculate it. Is it clear? Yes, no, anything. Okay. Answer, like I'll tell you what answer is in a moment. Like, okay, let's cover that thing only first. What is the answer? Answer is nothing but, see, if my zeroth song, like the first song, if my first song, if my first song started at x, then it will be definitely getting played at x.5, right? X plus 0.5, right? It will be definitely getting played. Why? Because the duration of every song is more than or equals to 1 and it is an integer, right? Yes, no. If my first song started at x minus 1, then I can only take this if the duration of the first song is at least 2. Because if the duration of the first song is at least 2, it started at x minus 1, it will play at x, and it will eventually stop at x plus 1. So it was playing at this x plus 0.5. So you just have to add probability of zero song, prob of zero song, not 0 1. Like I've taken it one index, right? So probability of this thing, probability of one song, this is the time. And what will be my time? Time is nothing but, you need to go from, x minus t0, like x minus time of the first song, like the duration of the first song, t1 plus 1. Why plus 1? I'll, like, just give me a moment, I'll explain this. You need to go from x minus t1 plus 1 to, you need to go till x. So you need to find the summation of this. What is the probability that you started your first song at this time, Why x minus t1? See, if x was something like, let's say, hey, take this example only. If x was 3 and time was, time is, let's say, ti is 2 seconds. So what is the earliest position that you can take? It is nothing but 3 minus 1, which is 2. So that is what you'll get from this also. So 3 minus ti is 2 plus 1. So this is nothing but 2. So you can start from 2 and you'll go up till 3. So all the songs that started at seconds 2 and 3, like all the, what is the probability of the first song starting at 2 and 3 summed up is your answer. Is that clear? Like, this is simple, just like adding, right? Okay. Now there is only one optimization that we need to do further. See, this probability of, making it a 2D array. Let me write it this. Here I'm making it a 2D array. But do I actually need to make this? See, what will happen if n is 10 to the power 3 and x is 10 to the power 4? Will make a 10 to the power 7 sized array. So is it really required to do this? See, I'm never using probability of anything other than probability. Like I'm using probability of 3 and something time. Never, right? I'm only calculating it here, but I'm not using it anywhere. So why calculate it? Because at the end, I only require probability of 1 and time. So why calculate other things, right? Why store them? So I'll just create, instead of creating this 2D array, I'll create a 1D array, simply like probability of time. And this is by default nothing but, this is nothing but prob, which was initially prob of 1 and time. I'm only calculating this for the first song, because I'm not doing anything with the other values, right? So why make a 2D array? Is it clear? Like I'm not using those values, right? So let me show you the implementation. See, first of all, I'm taking n and x as input. Then I'm taking all the time values as input. So this is probability for the first, like what is the probability that the first song will start at this time, like any time for time 0, time 1 up till x. So this is that vector. Now inverse is nothing but this inv is power of n, like n to the power mod minus 2 under some, like that mod is nothing but that was given in the problem. So this is nothing but 1 by n under modulo. You know this thing, right? Inverse. This is using binary exponentiation. Now this is probability 2. So probability 2 is nothing but what is the probability that you'll have to choose some song at this ith time. So initially probability of 0. Probability of 0 is nothing but what is the probability that the first song started playing at 0th time is 1 by n. And for all the other, like for all the songs, since each song has a probability of 1 by n, so probability 2 that you'll have to choose a song at ti moment is gets added by inverse 1 by n. Now for like this j is nothing but time. So from time 1 to x, I'm doing, it's like earlier I was doing this inside this flow, but there is no point, I'm not doing this for each song, so I can do this outside also. So probability that the jth song started playing at this time is nothing but what was the probability that I had to choose a song at this time into 1 by n, because there are n songs again taking mod. And then for each of the songs, if ti plus j is less than or equals to x, that means once like you selected at this ith, this jth time, you are going to start playing ith song. So if the time at which this song will end, this is the time at which this song will end, is less than or equals to x, probability 2 that is giving you that probability that you have to choose another song at this time will get added by probability 2 that you have to choose a song at this moment into 1 by n. Again taking mod. Finally, the answer is nothing but start from x and go up till x minus t0 plus 1. I'm having this more than, I can have this like this also. So this plus 1 and then this will be 0. This is 0 ll, just so 0 long. So start from x, go up till this thing, and keep decreasing your j by like j in each step by 1. And finally, your answer is nothing but answer plus probability that your first song started at this jth time, percentage mod. Because if it started at jth time, it will be definitely getting, it is definitely getting played at x plus 0.5 time. Finally, you can print your answer. Is that clear? What do you mean real number? Probability 2 is also like, it is just the probability that you will have to choose another song at ith moment. What is the probability of that? Okay, so that's it, and thanks for joining. Bye bye.